Let's take a look at topic 5.3, graphing radical functions. And in this section, we're more so going to focus on transformations of a radical graph. So here's our standard form radical function, and this should look relatively familiar to you. If you have a number out front, that's your A value. It's a vertical stretch or compression. If A is negative, you know it's reflected across the x-axis. Here we have an H, and again, notice it is with the X. This is going to be a horizontal movement, and that means this is going to move your graph, the graph of your parent function, either left or right. And your K value, the value that's always hanging off kind of to the side, that is going to be your up-down. That is a vertical shift. So here we go. Let's take a look at some parent functions. First of all, let's look at the square root function. Now, remember, radicand cannot be less than 0 because if we have a negative number underneath the radical, that gives us complex numbers. So your domain has to be x is greater than 0. You can only choose greater than or equal to 0. Choose any numbers 0 and higher. So when I did a table of values for my parent function, I'm just looking for easy numbers. I'm looking for perfect squares. So 0, if I take the square root of 0, I get 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 16 is 4. And then this is kind of a rough sketch. I know I'm not an artist. Of the square root function. We're going to take a look at this on Desmos. Notice here again, your domain is x such that x has to be greater than or equal to 0. You will never have any negative values for x. And then your y has to be greater than or equal to 0, because of course if we're inputting those positive numbers into a square root function, we're only going to get positive numbers out. Let's take a look at this on Desmos. So here it is. Here's our parent function for the square root. And now let's just play around and take a look at some transformations. So let's do square root x, let's do a -1. And again, notice that negative, even though it's negative, remember that's part of the standard form of that radical. That means your h value is positive. So I am moving to the right one. If I change this to a positive, notice it moves left. Your h value is now a -1. And again, if you were to plug in -1 into your standard form, you'd have x minus a -1. Negative makes it positive. Let's take a look at what happens. Let's take this out. And let's put a k value in. Let's go. It moves it up 3. Moves it down 3. Let's stretch it. 5 up front. It's stretched. And notice how it's kind of pulling closer to the y-axis. If I make that a 0.5, so like 1/2, it compresses it. It's pulling it closer to the x-axis. If I make this negative, it flips it, just reflects it right over the x-axis. Now let's take a look at cube roots. So here's your cube root. You don't have any restriction on your radicand in a cube root, and your parent function is just the cube root of x. So now when I'm doing my table of values, again, I choose perfect cubes, and here I can go into negative numbers. So the cube root of -8 is -2, cube root of -1 is a -1, etc., etc. Again, a very rough sketch of the cube root function. Let's take a look at Desmos. And let's pop in a cube root function. And I want a cube root and x. There we go. There's our parent function. Now let's play around a little bit. And again, if I go x, let's go x minus 1. Notice my graph moves right. And you see where it's kind of flat here? That's called the inflection point, where the graph kind of flattens a little bit. Watch that as you're doing transformations, or if you have to pull an equation from a graph. Take a look at where that point has moved. I can also change this to a plus 1. We go left. And now let's just go ahead. Let's go plus. I moved it up. Minus 4. It goes down. And again, if I stretch it, it's pulling closer to the y-axis. If I compress it, multiplied it by a half, it's pulling in closer to the x-axis. Now, if I make this negative, it reflects it across the x-axis. It just kind of rotates it around there. So now let's just take a look at a few. And we're going to identify the transformations. So here on A, I have the parent function is the cube root of x. And if I look at this, I don't have anything out front, so my A value is just 1. Here's my H value. Now, if you see that this is positive, your H value is negative 1, which means I am going left 1 unit. Here's my K value. K is negative 2, which means I'm going down 2. I'm moving my parent graph down. I've moved it 1 to the left and then down 2. On B, notice this negative right here. That means we are reflected across the x-axis. It's just an A equals negative 2. So it's negative 2. That negative is the reflection. The 2 is a vertical stretch. Underneath the radical, my H is a positive 3. So that means I'm going, moving my parent function right 3. And my K value is a positive 4, which means I'm going up 4.